All right, here we are back again. We are going to work on the warm-up just like the last 2 days. Please try to do as many as you can. Stop the video and start it up after everyone's at least done the ones they're capable of doing. All right, let's get started. I'm going to just solve these and we'll move on to the lesson for today. So you're going to draw a line, locate the variable. These are one of our very basic solving. So we go through all of them here. So the opposite of subtracting 10 would be adding 10. And x is equal to 14. So hopefully you all got that one right. Then we move over here. S, that's an S. S plus 5 equals -2. So again, the opposite of adding 5 is subtracting 5. Oops, I didn't circle the variable. And we have S equals -7. Those were one-step simple ones. This one also is a one-stepper. But hopefully you didn't get tricked, because this came up yesterday when I just did that other lesson. It's not add 8. It's -8 times y. So you're not adding, you're dividing by a -8. Y is equal to -4. Over here, we are solving, but what is the problem? M is trapped. Yes, it is. It cannot get out of there. It is trapped with that 4. Don't you try to separate them, right? Because it's grouped up above because of this big division. What do you have to get rid of first? The 2. So we're going to multiply by 2 on both sides. 2's cancel. I should use a dot, not an X. That makes it more confusing. I'm left with m plus 4, and then finally they have freedom and they can separate from each other because it's not being trapped by this bar. Now we have the just simple equation. We're going to subtract 4, and m is equal to 10. So how are you doing? I hope you're getting some of these right, guys. We will go over, more questions when I come back, but hopefully going through all these lessons, you should be able to get the majority of your work done here. This is an equal. I don't think that's a negative. Sorry if you thought it was a negative. Yeah, so x minus 5, so the opposite of subtracting 5, and you can change the sign on it if you'd like. Either way you do it, it's still going to be a plus 5 there. -14 and a +5 is a -9. If you're still having trouble with those signs, we got to chat, okay? Because you can see they come up constantly. Draw your line, locate your variable, which is a t. Opposite of PEMDAS means you're going to add subtract first. 2t is left. 45 minus 5 is 40. Now it's 2 times t, so I'm going to divide by 2. And t is 20. All right, so once you get done with that, go ahead. We're going to flip it over and take a look at the homework for today, which is on absolute values. We talked about absolute values already this year, didn't we? We talked about the absolute value of -4 is 4. The absolute value of 4 is 4. It's always a positive value because it represents a distance on a number line from 0. Okay, so 4 is 4 units away, and -4 is also 4 units away. Now, when we get to solving, some different rules come in. Let me see if I can sharpen that up a bit. So when we have the absolute value of the variable that we're solving for is equal to a, it means what values of x have an absolute value of a. Solutions are a and -a. So when we have, for example, the absolute value of x is equal to 5. Let's talk about this now. I could put a 5 in here and get 5, or I could put a -5 in here and get 5. Right? Just like this one up here. I had a -4 in here and a +4, and they both equaled 4. So if we're looking for 1 and we're trying to figure out what goes in here, both a 5 and a negative 5 will yield a 5 once it's placed inside there. Okay, so let's do an example, a real quick one here. Absolute value of x equals 12. I want you to tell me it's going to be either this or this. What would you put in there? 12 or negative 12. If I put a 12 in place of x, what's the absolute value of 12? 12. If I put a negative 12 in place of x, what's the absolute value of negative 12? 12. Okay, so that's pretty straightforward and simple. There's 2 solutions. There's always going to be 2 solutions. But when there's other solving involved like there is here, it's a little trickier, so you got to be careful. Your first step is to move everything outside of the absolute values. Okay, and that's on the same side of the equation. So let's look at what I'm talking about. When you draw the line and you locate the variable, and I'm just looking on the side that has the absolute value. Do you see the absolute values? Let's put them in a different color so they jump off. What's outside of those absolute value signs? There's only one thing. Oh, do you hear that? Some birds out there. It's the 3. Okay, and what is happening here? It's 3 times that absolute value. I have to solve and move that 3 first before I can do anything with the absolute value. So what's the opposite of multiplying by 3? Dividing. So I divide the whole shebang by 3. The 3's will cancel. And I'm going to move over here just because I'm running out of room. What's left over here? Absolute value of x plus 7 equals, what's 24 divided by 3? 8. Okay, so again, we have this now. What did I tell you about absolute values? How many solutions? 2. The biggest mistake that is going to be made, if any of you make it, is that you're going to give me 1 answer tonight on the homework. There are 2. And to help you remember, whenever you see this absolute value sign, what we're going to do is we are going to break this. I'm going to put a little diagram here, and I'm going to put the 2 arrows coming off of it. And the reason I'm putting 2 little arrows there is because there's 2 answers. And there's 2 equations that you're going to have to solve to get those answers. One equation is going to look exactly like this without those signs. So we're going to remove these signs and do x plus 7 equals 8. Do you see how it's exactly the same without those absolute values? The other one is going to be the same, except instead of an 8, I'm going to write a negative 8. X plus 7, so the inside here stayed the same, equals a negative 8. Now, when I solve both of these, I will be done and have my answer. Draw your line, locate your variable, subtract 7, x equals 1. Or, I got to do the other one now. Draw your line, locate your variable. You may think you're going to get the same answer, but you're not. Because watch what happens. X equals what? That's not 1. That's negative 15. There's my answers. 1 and negative 15. You might want to highlight those so tomorrow when you're doing your homework you can find them quickly when we correct. And you might say, how can that be? Well, let's look. 3 absolute value of 1 plus 7 equals 24. That's the first one. I just put a 1 in there. Let's see if that works. What's 1 plus 7? 8. What's the absolute value of 8? 8 times 3, 24. Yay, that works. Let's try the negative 15. 3 negative 15 plus 7 equals 24. Let's try that. What's negative 15 plus 7? Negative 8. What's the absolute value of negative 8? 8 times 3, 24. So it does work. And that's what you have to figure out, and that's how you do figure it out. Again, notice what changed. I have the positive 8 and a negative 8. I took this value right there, and one of them was positive and one was negative. What was inside the absolute value is exactly the same. I just removed those goalposts or signs. Okay, so let's practice. We have this one to do. If you want to stop and have kids try it, that's fine. Otherwise, I'm just going to keep going here, and you can make that decision. So you're going to draw your line. You're going to locate your variable. Okay, remember what I said? Now, everything outside, back up to this, everything outside of those absolute values has to move to the other side. So here's my line. Here's my absolute values. What's outside of it over on this side? Right there. In that case, it is not being multiplied. It's an absolute value minus 8. So what am I going to do? I'm going to add 8 to both sides. So what's negative 8 plus 8? 0 equals absolute value of x plus 2. I don't like having that on that side, so I'm going to move it over here. I'm going to put the 0 on the other side, because guess what? You can do that. I'll get out my handy dandy little whiteout and let's take care of business. There we go. Now, we are going to normally split it up, and I'm going to have x plus 2 equals 0. I'm going to have the exact same one I have here. And I'm going to go over here, but what? Well, it should be a positive and a negative, but we can't have a positive and negative 0. So here is one situation. This is a special situation. We're only going to have one answer. We're going to draw the line, locate the variable, and solve. X equals negative 2. Okay. There are some special situations like that, and that's one of them, when you have an absolute value and it equals a 0. All right, let's look at the bottom one here. Now this we can't say, oh, it's equal to 0, there's 1. No. You have to move stuff first and then determine it. So here's my absolute values. What's on the outside of those, on that side of the green line? 3. So what are we going to do? We're going to move it. What's before the 3? It's positive. We're going to subtract 3. So I have the absolute value of x plus 4 equals a negative 3. Normally, I would draw my line just like I did here, my little arrows in here, and I would normally do it here. But this is another one of those special situations. Does anybody see a problem here? The absolute value of x plus 4 equals negative 3. What did we say at the very beginning that absolute value was? A distance from 0. How can a distance be negative? Can't. Okay? There is nothing on this planet that you're going to, no real number that you can put in for x and make this true. Try it. 1 plus 4, I'm going to get 5. What if I put a negative? Let's try it. Negative 7. Let's try it. Negative 7 plus 4 equals negative 3. Oh, that should work, right? Negative 7 plus 4, that's a negative 3 after all. Well, what happens when you do the absolute value? It's a positive. No matter what you put in here with those absolute values around it, you're going to get a positive number equals a negative. So when you solve and move things, excuse me, and you're down to an absolute value only with stuff inside of it, and it equals a negative, it's a special situation. And here's the deal. Let me get a nice, brilliant, sparkly pink pen. No real solution. Or just no solution would be fine too, if you wrote that. Is it sparkly? Let's see. Oh, there, do you see it? Okay, that's really a bummer. Okay. So, you can write no solution. Let's take a look down here. Last one. A support beam for a building must be 3.5 meters long. It is acceptable for the beam to differ from the ideal length by 3 millimeters. Write and solve an absolute value equation to find the minimum and the maximum acceptable lengths. So if we're trying to find that, we can use absolute value here. So we know that the difference between this, so the variable is x, can be off by what? 3. Find the minimum and the maximum. These are the minimum and max, the extremes. Not everything in between. Because if it was everything in between, we would need an inequality, a greater than or less than sign. And this is 3.5 meters. Uh-oh, we have a differential of units here. So how can I change? Let's just change, since this is millimeters, how do I change that to millimeters? Anybody know? 3.5, 1, 2, 3. Hops over 3 spots, 3,500. So the acceptable lengths, here we go. So x minus 3 equals 3,500. Or, now how did I get the second? Oopsie, sorry. How did I get the second one? One of them looks just like this without the absolute value. The other one looks just like this, but it's a negative. And that's what you have to remember. This is the thing that's different. This negative is what makes them different. Draw a line, add 3. X is that. And add 3, whoopsie, I'm getting out of space here. Negative 2, 4, 9, 7. I just subtracted that in my head because I had a negative 3,500 and a positive 3. So that would mean that I have more negatives. How many more? Well, I subtracted that. I just did that in my head. I backed it up 3 spots to 97. You could go over there and do that, though, if you wanted to. But here's the difference. I want to switch it back so that it's in meters. So I need to move the decimal 3 spots again. So there's it. The biggest it could be is right here. 3.503 meters. The smallest it could be is negative, wait, what? Wait, hang on one sec. Okay. It's gone because I made a mistake. So when I was looking at this and I was getting that negative down there, I'm like, well, it can't be a negative. Like, even though I knew the number positive was right, I'm like, wait a minute. I'm missing something. I didn't want to waste your time. So I was looking at it and I'm like, yes. I had these two numbers mixed up. So it said the support beam must be this. It's acceptable for it to differ by this much. So it's saying when you have the support beam and you're subtracting the 35, it's okay for it to be 3. So I had those two numbers flipped, and now although the numbers themselves will be the same, it's the signs that were bothering me. So when you split them up, watch what happens now. X minus 3,500 equals 3, the positive, and then x minus 3,500 equals negative 3. So now when you draw the line, look at, I'll still get the same answer here. So you're like, okay, x equals 3,503. You're thinking, why are you doing this? Same exact answer. It's this side that was the problem. So this was a minus over here. It's hard to see because of my extra. Let me rewrite that so it's clear. That was a negative 3. And then a positive 3,500. So you still would subtract. It's still going to be 2497, but it's positive. Okay, so the values it could be, and if again we switch it back 3 spots on both of them, the biggest it can be would be 3.503, and the smallest it would be able to be is 2.497. So that is your max, and that is your minimum. Does that make sense? All right, sounds good. See you soon. Bye.